day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Matsidiso Kongwani. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Remember, grade 12s, for any clarity-seeking questions, you are more than welcome to send your message to our WhatsApp number, which is 079 578 2908. I'm repeating it again. It's 079 578 2908. Okay, grade 12. Today we'll be looking at integration, but our focus will be only on the indefinite integral. And then after the completion of the lesson, you will be able to integrate the following forms of integration. We have our f at x, f at k, x to the power n. In terms of x, we are deriving kx to the power n in terms of x, integrating kx to the power n in terms of x. If that is the case, therefore we will be following that rule, grade 12. That means this is indicating the rule for each and every integral. And then now the second integral here, we are having integrating in terms of x, the k over x there. Therefore your answer will be k in x. Remember the plus c to show that we have integrated, and therefore the value of x must always be greater than 0, meaning that the value of x must always be a positive value. And then now we are integrating in terms of x, the k n x as an exponent. Therefore, if that is the case, now your answer will be k a n x, and then the in over in a plus c. Don't forget that plus c, it shows that you have now integrated. And then the a value must be greater and equal to 0, meaning it must be positive or equals to a 0. And then now k and a must always be element of real numbers. Okay, and then now secondly, you will be integrating polynomials consisting of terms above the forms of all of the above forms, grade 12. So that means now you are having those integral rules, but the minute we apply them in the polynomial, you will be requested to apply all of them into that particular polynomial. Right, and then this integration is the reverse of the differentiation that you will be doing under the topic differential calculus. That simply means now the reverse of differentiation, of which is the antiderivative, is called integration. That means grade 12 now, if I am differentiating the x squared, my answer, because I am differentiating, it will be 2 times the coefficient, and then we subtract 1 from the exponent. Hence, that will be your answer. But if we take this answer that you have differentiated, if you integrate it, it will take you back to an expression that you were having before you differentiate. That is why we are saying differentiation is the reverse of the integration, or vice versa. And then now we have a rule that we are following now. Okay, before we go to the rules, grade 12, let's understand the meaning of each part on the notation of the integral. This symbol here indicates the integral. That means it's an integral symbol. And then the k x to the power n is an integrand. And then the dx there, it means that we are integrating with respect to x. So this means with respect to x. That is an integral symbol, that is an integrand, that is with respect to x. I hope now you understand the language that we will be using throughout this presentation. Now let's look at the first rule and its application. Remember, we are busy with the indefinite integral, and then we are looking at the integration rules. We are having different types of them, and then we are looking at rule number 1. So in rule number 1, we are having 2 notations. That is the integral with respect to x, and then the integral of k with respect to x. So we try to bring in the different types of notations. And then let's look at the first problem then. And then it says determine the following integral. The first one we are given the integral with respect to x. But if you look at the expression and there is no expression next to that, integrand is not there. And then now in that case, grade 12, because you are integrating in terms of x, you must include that. This simply means now this integral is, we are integrating x to the power 0 with respect to x. That is why they don't write any value here, because x to the power 0 is a 1. So this simply means there's a 1 there. And then if you compare this to the rule there, 1.1, it states that if you are integrating a 1 with respect to x, your answer will be x plus c. Let's see how do we come up with that answer now when we apply the rule now. Our rule states that now we will be looking at the x to the power 0. Remember, when we integrate, we say plus 1. Okay, we don't write that integration anymore. And then divide by whatever you have added on the exponent there. As you can see, we are having a 0 plus 1. 0 plus 1, we know it's a 1. That means this will be over 1. And then now we are going to add plus c because we have now integrated. Can you see grade 12? We don't have any integration symbol anymore. Therefore, we'll be having a plus c there. And then our answer will just be a what? An x to the power of 1. Because now it's 0 plus 1, which is a 1 over 1, which is just be x plus c there. Can you see? It's exactly the rule that we have identified above there. So be careful. If there's no value here, you must know there's a 1, and then that one is representing x to the power 0. Coming to the second one, 1.2, we are given that we are integrating, determine the following integral integrating a minus 10 with respect to x. But if you look at this minus 10 is not having any x, grade 12. That means again we are bringing what? An x to the power 0, because minus 10 times 1, it is still a minus 10. So this will be minus 10, and then we are representing that 1 as x to the power 0 there. Remember, it's multiplication by 1, which is still the same thing. And then we are integrating that with respect to x. And therefore, we are following the rule now. We are having a minus 10, x to the power 0. Remember, the rule says plus 1, and then over the exponent of your x there, that will be 0 plus 1, which is 1. Therefore, this is over 1 plus a c. And then now our final answer will be what? A minus 10 x to the power 1, grade 12, plus a c. Can you see that? You are having a constant number there. If you are having a constant number, your integrated answer will be that value that we are having there with an x plus c. That is what 1.2 rule is telling us. Okay. And then 1.3, if you look at this one now, you are having x to the power n now. Remember, previously we were busy with x to the power 0. In this case, it's x to a certain number. That n can represent any number there, a positive number, right? And then now, the rule states that you are taking x and then you add plus 1, and then that exponent will go on the denominator there. That is the integration. Remember, you must also add a plus c. That is our rule, grade 12. And then let's apply the rule now to integrate x to the power 5 with respect to x there. So the rule states that now your answer will be x to the power 5 that was given to you, and then you add a 1 there, and then that exponent will now be your denominator, which is 5 plus 1 plus c. Hope you are still together, grade 12. And then now this gives us an x to the power 6 as being our answer. over a 6, and then remember now it is plus c. And then now sometimes this can be written as 1 over 6, the same thing, and then you can just put that x to the power 6 on the side there, and then this is a plus c. And grade 12, why are we saying this is the reverse of the integration? Remember now, when you are integrating this value that you are having here, we are having 1 over 6 x to the power 6 as our expression, and then when we apply the differentiation rule, it says 6 times the coefficient and then you subtract 1 from the exponent. That will be 1 over 6 times the 6 x to the power 6 minus 1. Okay, and therefore this will give us a 1 over 6 times 6, it's a 1, therefore it's an x, and then 6 minus 1, it will be a 5. Can you see now? This expression is exactly the same as the original that was given to us. That is why we are saying integration and differentiation, they have a relationship. If you reverse one, you get the other one. And then we are still on rule number 1. And then with the 1.4 there, we are given now, look at this now, it is still the x to the power n that we were busy with on the previous question, but for this one we are having the coefficient now, of which is k. Can you see now you have a value before your x and the value on your exponent, of which is a positive exponent, grade 12. And then now let's look at the question there. And then from that one now we are having integration of 6 over x to the power 4, and then we are integrating this in terms of x, grade 12. And then let's see now, we cannot, remember there are rules that you apply on differentiation that you can't derive when you have bracket, you can't derive when you have a variable on the denominator. Simplify your fraction as far as possible. The same applies here. We cannot derive this x to the power 4 being on the denominator. So we are going to move this to the top, and then this will give us an integration, because we have not yet integrated, of 6x to the power minus 4. Remember, if it was a positive exponent on the denominator, when you move it to the numerator, it will now change the exponential sign to an opposite one, of which in this case it was a positive 4, it is now a negative 4. Remember, we are deriving with respect to x. And then now, since we have removed that denominator, now we can start integrating. The minute you start integrating, you don't write the integral sign, okay? And then that means now you have your 6, yes? And then this will be x to the power minus 4, and then plus 1, and then everything now minus 4 plus 1. Your denominator must always be your exponent as it is, okay? And then since we have integrated, this will be a plus c. And then let's simplify now, grade 12. We are having 6 x to the power minus 3, and then over minus 4 plus 1 is a minus 3. We'll continue simplifying. A minus 3 into 6 is a minus 2x to the power minus 3. Remember, there's a plus c, grade 12. You must also bring that plus c as you continue writing your answer. If the examiner states that your answers must not have negative indices or exponents, that means you must get rid of these negative exponents by taking this x to the power minus 3 to the denominator again, back to the denominator, and then this will change to a positive exponent 3 there, and then plus c. That is our answer, grade 12. Okay, move on to the next one, and then for the next integration there we are given integrate x over 6 with respect to x, okay? Remember, I've indicated on the previous activity that this is the same as 1 over 6x, and then we are deriving with respect to x then. And then now let's apply the rule. We are now integrating with 1 over 6, and then we have x. Remember, this is x to the power 1 if we don't have an exponent. Therefore, we will say 1 plus 1. And then whatever we are having as an exponent will also be our denominator there. Do not forget the plus c great terms. And then this will be 1 over 6 x to the power 2 over 2 plus c. Can you see great terms? The final answer thereof will be 1 times x squared, which is x squared, and then 6 times 2, which is 12, and then the plus c. Okay? Do not confuse this grade 12. You have your formulas on the formula sheet. Okay? And then now we move on to rule number 2. And then rule number 2 also have 2 types. And then with 2.1 there, it states that if you are having an integral of k over x with respect to x, after integrating, your answer will be k. That means the top part here is represented here. And then this will take a ln x and then the plus c. Okay? That simply means, now be careful, grade 12. On the previous question, we were having x over 4 as x to the power 4 as a denominator. It's only when that you can take that up. But the minute it is x to the power 1, that means you need to apply this rule number 2. You can't take this to the numerators. If I'm having 1 over x, I can't, or let's say 2 over x, I can't write this as 2 to the power 2x to the power minus 1, because there's a specific rule that is addressing this type of integral. It's not the same as when you are having 2x to the power 3. With this one, it's a must. You must take that up to be 2x to the power minus 3. I hope you get the difference, grade 12. With this one, you can't do this because there's a rule that is talking to that. But with this one, we are applying the previous rule. Okay? Right. And then now rule number 2, it works with a denominator x to the power 1. All right. And then now let's look at the example there. Integrate 7 over x with respect to x. And then now, since the x is x to the power 1, that means we are applying this rule. It says that take the constant value, the top constant value, of which in this case is 7. That means grade 12 will be following this rule, is at the back of your formula sheet. And then now you'll be having a ln of x plus c. That is your answer, grade 12. As easy as that. Okay? Remember, this is not 71, it's a ln of x. And then let's look at the second one now. The difference between the first and the second one is that your expression here is given with the -1 being an exponent. So you need to deal with that one before you start integrating. And then how do we do that? You change the position. It is on the numerator, you now move it to the denominator. And then now, that means, now let's look at the example there. We are going to take this integration, we leave a -6 there, and then we take back this x to the power minus 1 back to x to the power 1. And then we are integrating this in terms of x. And then now, can you see now it is on the same format as the previous one? And then now our answer will be, we take the constant on top, -6, and then now we have the ln of x plus c, because we have integrated. Okay? That is your answer, grade 12. So be careful of denominator x and the x to the power -1. That is having a specific rule that is bringing in a ln. Okay. And then rule number 3 now, that is the third rule. With this rule now, we are having x being on the exponent. Can you see the difference now? Our x is on the exponent now. We have a value there, and the value as being the coefficient of x there. The value of a and the value of n being the coefficient of x. This rule says that you take the whole expression as it is. That will be your numerator on the integrated answer. And then denominator will be the coefficient of x. Can you see that n value is the one that will be represented there? And then with the ln of the value of a there. And then the plus c. Let's see now, grade 12. Can you apply the rule now? Right, we look at the expression first. It is 8 to the power x. Can you see the coefficient of x is 1 in this case? It is there. It is 1. You know, when it is 1, we don't write the value, grade 12, okay? But we know there's a coefficient 1 for x there. Remember, 8 is the base, x is an exponent. So coefficient of our exponent is 1. Now, let's follow the rule now. The rule says take expression as it is, that is 8 to the power x. On the denominator now, take n. N is the coefficient of x. In this case, it will be 1. So it's fine if you don't write it, but you can even write it to remember there's a 1 there. And then now we have a ln of a. What is the a value there? The a value is 8. And then the plus c. Don't stress about the rules, grade 12. They are at the back of your question paper. Yours is to compare the type of question that you are having versus the rules at the back of your question paper, so that you select wisely so the correct one. Okay. Now let's look at the second one. Okay, in this case the coefficient of x is 4 there. That means you can even maybe write the value. Okay, the value of a will be 2 and the value of n will be 4. Right. And then take the rule as it is, that this will be the rule a to the power nx. I have checked on my formula sheet and selected the correct rule that goes with this type of expression, and the plus c. And then from here now I can now substitute, because I have identified my a value and my n value there. Remember, the top part is exactly what you have, of which a is 2 and then n for x there, which is that expression. And then all over the n, which is 4, and then you have the ln of a, which is 2, and then the plus c. I hope this will also assist you, grade 12. That is another alternative way that you can apply to assist you in terms of identifying the values and then matching them with the correct application in terms of selecting the correct rule at the back of your question paper on the formula sheet. And then now we are looking at another type here. We are still on the same rule number 3, but a little bit modified. And then now with 3.2, we are having k a to the power nx. Now there is another constant value next to your a there. And then now with the coefficient there. And then this rule says you are taking the same expression as it is. And then on the denominator now you'll be having n and the ln of a plus c there. Okay, that is the 3.2 there. Okay, let's see grade 12 now. Let's identify. As you can see, you need the value of n and then you need the value of a in order to have the correct answer there. So now we are going to look at this expression that is given to us, the number 1. We are integrating 5 times 3 to the power x with respect to x now. And then now what is the value of n here? The n value is equals to 1. And the a value is equals to 3, grade 12. Do not touch that 5 that is in front of your 3 there. The only a value is 3. Do not multiply and say 5 times 3 is 15. That is not allowed, grade 12. You leave it as it is. You follow the rule exactly what the rule says to you. Okay, and then now following the rule, now let's see what does this rule say. It says take your expression as it is. Okay, we will be having the same 5 multiplied by 3 to the power x all over, and then for the denominator it says write the value of n. In this case it's 1, and then your ln, and then of a, of which is 3, and then plus c. That is your answer, grade 12. Can you see? I didn't multiply any 5 by 3. Okay, let's move to the next one. Again, here you cannot say 8 times 3. You cannot multiply grade 12. We are following the rule. The rule states that take the expression as it is. That will be the 8 into 3 to the power minus 4x all over. Remember, on the denominator we need an n and a. Can we identify the n and a now, grade 12? What is the value of n? N is the coefficient of x, of which is minus 4 here. And then a is that base of the exponent, of which is 3. You can't bring in the 8. Okay? When identifying n and a, 8 is not part of that. That k value here is not part of the denominator there. So now, for this one, the denominator will be n in a. So what is n? Minus 4. And then we have the ln of 3 there. And then remember your plus c. So that is your answer, grade 12. Okay? And then these problems, they worth 2 to 3 marks. It depends on the examiner. They can 1 mark for the top part, 1 mark for the below part, and then the 3rd mark will be for plus c there. So if it's a 2 mark, they will mark the integration and then another mark for plus c. So this plus c is very important, grade 12. Right, and then now we move to what we call the integrating polynomials. Right, grade 12, I'm giving you 3 minutes to try this one. Before you do it, remember you compare with the rules. You are having your rules on the left hand side here, and then we are integrating individually, so relating this to the rules that we are having on the right hand side. Let's check, grade 12, how far can you go with this one? Okay, grade 12, let's see how far did you go with this one. Remember, you are more than welcome to send your clarity seeking questions or any alternative solution or any method that you want to share with us to our WhatsApp number 079 578 2908. I'm repeating it again, grade 12 079 578 2908. Let's see how much can you get out of this one. Now the tip around this one is that grade 12, remember, I've indicated to you earlier on, if there is a 3 there without any x value there, that means it's a 3x to the power 0. Okay, so that means here we are having x to the power of 0 there, of which is not indicated. All right, and then from here now you check the rule that is relating to each type. When you deal with polynomials, you do it as if you are integrating separately. So for example, it looks like you are looking for the integration of 3x to the power 0 plus the integration of x to the power pi minus an integration of 4 over x plus an integration of 5 over x to the power 6 with respect to x. It will be easier now if you separate them like this and then you compare this. Rules will be at the back of your question paper, exactly as I've indicated them here. Yours is to relate now and check which ones are having a relationship. For example, now we are looking at 3, it's a number x to the power of 0. Can you see that is having a relationship with that one? There's a number there and number there. And then x is a base. So now you can take this rule, grade 12s, and follow the rule in order to answer that question. It is saying now keep the constant 3. Can you see that? So you keep 3. Because you are integrating now, we don't write integral sign, right? So we leave a 3, and then it is x to the power 0. This rule says add 1, and then take that exponent to the denominator. So we add 1 there, and then we take this to the denominator, 0 plus 1. We are done. Partial integration, all right? And then now we have plus here. And then now this is x to the power pi. Remember, pi is a number, grade 12. It is 22 over 7 fraction, all right? And then rounded off 3,14. So that means it's the same rule where we are having x to the power x to an exponent number. So it's that rule. So now look at the rule. It is saying add 1 to the exponent and then take that exponent to the denominator. Yours is just to relate and apply, grade 12. And then these are free marks, right? And then this will be x to the power pi plus 1. And then you take that pi plus 1 to the denominator. Okay, move on to the third one. This is now 4 over x. Our x exponent is 1. So that means we are having a number on top which is 4 over x. That means is this particular rule, grade 12. Can you see that? And then now it is telling you exactly what to do there. It says take the top part k. Okay, that will be 4. And then now you have a ln there. Oh, I'm bringing in a ln. And then it's the ln of x. Can you see that? We'll add the plus c at the end because now it is represented as a polynomial. We will only have 1 plus c. We can't write plus c for each and every term. We are going to have only 1 for the whole of this polynomial, right? And then now let's integrate the last one. We are having integration of 5 over x to the power 6. And then we move back to our rules and check which one is having 5 over x to the power 6 now. Okay. Oh, it does not belong to this one because these ones are only for x to the power 1. So if it is something greater than 1 or a negative 6 or something, you must take this again to the numerator. So this means now this can be noted as 5x to the power minus 6, grade 12. Okay, so now if we are integrating that, it will be 5 x to the power minus 6 plus 1, and the denominator minus 6 plus 1. Then you can now bring in a plus c there. Simplifying now. Let's simplify and have the final answer. We are having 3. 0 plus 1 is 1. That will be x to the power 1. Then it gives us a 3x. Plus, and then for this one, we can't do anything to that one. You leave it like that. X to the power pi plus 1 over pi plus 1. And then minus 4 ln of x, it's fine. And then for the last one, we are having a plus. Remember, this will be minus 5. Minus 6 plus 1 will be a minus 5. Then a plus 5 divided by minus 5, it's a minus 1. X to the power minus 5. Remember, 5 goes once there. We don't have that 5 anymore. And then this will be plus c there. If an examiner says with positive indexes or exponents, that means you need to get rid of that one. No negative on your exponents, on your final solutions. We are just targeting that last one where we are going to get rid of the exponents. So we write everything as it is, minus 4 ln x, and then this one will be minus. Remember, there's a 1 there that we don't write normally. If it's a coefficient of x, that will be minus 1 over x to the power 5. Now, because we have moved x to the power minus 5 from the numerators to the denominator, it is now a positive 5. And then the plus c. Can you see now? This formula sheet will assist you to make your life easier in terms of applying the correct rules, grade 12s. Let's move on to the next activity. Can you see now on number 2 again? We are saying relate. We are having 3x to the power 1. Can you see that is the first one? 3x to the power 1. And then we are having 1 over 3, x as being the denominator. Can you see x to the power 1 is on the denominator? That means we are taking this rule here. And then we have minus the square root. Then this square root we need to change to x to the power half now. That means it will be the first rule there. Remember, this is rule 1, rule 2, rule 3. And then now we have 4 to the power x. It's a constant number to the power x. If x is on the exponent, that means it's rule number 3. If x is on the denominator, which is x to the power 1, is rule number 2. Anything else is rule number 1. I hope you get it, grade 12. I'm repeating again. Rule number 3, x must be on the exponent. Rule number 2, x must be on the denominator. It must be x to the power 1. Everything else, rule number 1. Okay? Now, let's see now. Let's start by writing that x in exponential form, x to the power half. And then we get rid of the set or the square root sign. That will be integration of 3x minus 1 over 3 is the same as we are multiplying with 1 over x there, so that we can have this integration there. And then minus x to the power half is the same as the square root of x. And then we are having plus 4 to the power x, and then we are integrating with respect to x. Now we can now start integrating. And then the first one says add 1, and then we take denominator to the numerator, exponent to the denominator, sorry. This will be 3 to the power x, 1 plus 1. Exponent to the denominator, 1 plus 1, it's a 2. And then the next one, we are having minus 1 over 3, but our focus is on this one. And then that 1 over x, remember it will be the ln x. You leave 1 over 3 because it's a constant value. That will be 1 over 3. And then this one will create a ln of x. And then now the next one, we are having minus x to the power half. That will be a plus 1. And then half plus 1 is 3 over 2. And then the last one is rule number 3, 4 to the power x. Rule number 3 states that if you are having 4 to the power x, you write on top it will be exactly your expression 4 to the power x. On the denominator, it will be the ln of a, of which a is 4 there. And then you have your plus c. And then let's simplify now to the final solution. We are having 3 over 2 x squared, yes, minus 1 over 3 ln x, yes. And then the next one now 3 over 2, and then now divide by 3 over 2 is the same as multiplying by 2 over 3. So that is a minus 2 over 3 x to the power 3 over 2 there in exponent. And then now plus 4 to the power x, and then we have a ln of x plus c there. Remember, this is not a 1, it's an I, which is ln of x, okay? And then now we are done with this number 2. Remember, do not forget to put a plus c there. Right. And then now the third one. With the third one, our challenge in this one, grade 12, we must ensure that we do not have brackets. We cannot integrate if there is something that needs to be simplified or multiplied out. So we are going to start by multiplying those brackets off. Okay, let's do so. Because we are busy simplifying, we will continue right in the integral sign. And then that will be x squared multiplied by 1 over x. Therefore, we'll end up with x to the power 1. And then x squared multiplied by x squared, that will be x to the power 4. And then remember, this one is the same as x to the power half. So it will be x squared times x to the power half. Remember, when you multiply the same base, you add exponent. So this one will give us x to the power 3 over 2. That is 2 plus half, which is 2 and half. So it's 5 over 2, grade 12. 5 over 2. And then we are deriving this in terms of x. And then now let's continue now. All right, we are relating this to our rules. Do we have x in the denominator or x to the power minus 1? No. Therefore, we are not applying rule number 2. Do we have a constant number to the power x? No. That means we are not applying rule number 2 and 3. So throughout this, we are only applying rule number 1. Can you see, grade 12? This can also assist you. Try to identify the rules that are applicable to your polynomial. And then now we are only applying rule number 1 throughout. So this will be x to the power 1 plus 1. 1 plus 1 is 2. And then plus x to the power 4 plus 1. 4 plus 1 is 5 on the denominator. Plus x to the power 5 over 2 plus 1. That will be 3.5, which is equal to 7 over 2. Therefore, this will be 7 over 2. And then now continue. Remember, you must add a plus c because we have integrated now. Now your final answer will be x squared over 2 plus x to the power 5 over 5 plus, if you divide by 7 over 2 is the same as multiplying by 2 over 7. Therefore, it will be 2 over 7 x to the power 5 over 2 plus 1. That is a 7 over 2 plus c. Can you see, grade 12? Do not cancel. Another misconception that you are doing, most of the learners will be cancelling these 2 as if they are dividing 2 by 2. You cannot divide. The division must be along. Remember, there's a 1 there. If there was a 4 there, then you say 4 divided by 2. But you can't take an exponent and divide by the denominator there. The same applies here. You can't say 5 over 5. So it's 1 over 5 actually there. Okay, so that is your final answer for that polynomial, grade 12. Right. And then let's look at this number 4. And then again with this number 4, if you look at this, we are having the denominator x to the power 5, of which is for the whole expression on top there. we need to simplify this before we can start integrating. So simplify your fraction as far as possible before you can apply your integral grade 12. Let's do so. We are still simplifying, so we will write in the integral symbol. So now we are going to divide this x to the power 5 in each term there. It will be 4x to the power 3 over x to the power 5. Separate them. X to the power 2 over x to the power 5 minus 3x over x to the power 5 plus 1 over x to the power 5, and then with respect to x. And then we are still simplifying, we will still bring our integral sign. And then for the first one now, we will be left with, remember we are having x to the power 3, it will take 3 from there, we will be left with x to the power 2 there. So it will be 4, x to the power 2, we take it up, it will be x to the power minus 2. Okay, and then now let's deal with the second one. It is x squared, and then out of the 5, 1 here, it will be left with 3. Then it's 1 over x to the power 3, of which we take this up, it will be x to the power minus 3. Remember, there's a 1 there. And then now to the next one, we are taking only 1x out of this, it will be 4. Then we'll be left with minus 3, and then we take that x to the power 4 to the top, it will be x to the power minus 4. And then now the last one, plus x to the power minus 5. I am taking x to the power 5 to the top, and then we are integrating with respect to x. And then let's start now relating this. Do we have a base with an exponent x? No, we can't apply this rule. 3. And then rule number 2 says you must have x on the denominator, or you must have x to the power minus 1. Do we have such case? No, therefore we can't apply rule number 2. So we are stuck grade 12. In all of this, we will be applying rule number 1. Therefore, let's go. Rule number 1 is 4x to the power minus 2 plus 1, and the minus 2 plus 1 is a minus 1. And then plus x to the power minus 3 plus 1, and minus 3 plus 1 is a minus 2. And minus 3x to the power minus 4 minus 1, minus 4 minus 3 is a minus 5. And then we have a plus x to the power minus 5 plus 1, sorry, it's a plus 1 there, that is a minus 3. And then minus 5 plus 1, minus 5 plus 1 is a minus 4. And then we have integrated, therefore we bring in a plus c there. And then let's simplify this now, grade 12. Our answer will be a 4 divided by negative 1, that is minus 4. X to the power minus 2 plus 1, it's a minus 1. And then plus, remember there's a 1 there. 1 divided by minus 2, it will be minus 1 over 2. And then x to the power minus 3 plus 1, it's a minus 2. And then now we are having a minus 3 divided by minus 3, it's a positive 1. And then x to the power minus 4 minus 1 is x to the power minus 3. And then here we have coefficient 1, that means we have 1 divided by minus 4, which is minus 1 over 4. And then is x to the power minus 5 plus 1 is minus 4, plus c. If now you need to get rid of negative exponents on your answers, then you can bring this back to its fraction now. Leave minus 4 on top, and then you take x to the power minus 1 to the denominator. It will be x to the positive 1 now. And then you have minus half, and then we take x to the power minus 2 to the denominator. It will join a 2 there, grade 12. Don't make a half and another fraction below that. It will join a 2 because 2 is already on the denominator there. And then that will be x to the power positive 2 now. And then we have a plus. Remember there's a 1 there. So you leave that 1 on top. On the denominator you bring in x to the power 3, of which will now be positive. And then lastly we have minus 1 over 4. And then this x to the power minus 4 will join a 4 there in the denominator. It will be now x to the power positive 4 plus c. Can you see grade 12? This will make your life easier. Your formula sheet will make your life easier. All these rules, you have them at the back of your question paper on your formula sheet. All right. And then now let's look at number 5 then. We are having integrate ax to the power b with respect to x where b is not equal to a -1. We cannot let a b be a negative number there, because if it is negative, you know what will happen, grade 12. We will show you this side after answering the question, what is happening if b is -1. Right, let's integrate this now. We relate to our question. This one, it says we have a being a coefficient. That means a and b, they represent certain numbers. Okay, so we have coefficient being a number there, and then we have b there. That means it's rule number 1, the second one, 1.2. Right, and then now this rule says that leave a constant value a, and then take x on the exponent, add 1, that will be b plus 1. Take the exponent to be the denominator, that will be b plus 1. Can you see grade 12? We have now integrated. Remember, if you have integrated, you must bring in your plus c. So that is your answer, grade 12. You can't simplify this further than that. Okay, now let's say we were having a case whereby this b was a -1. Can you see that? If it's a -1, if we are writing this back to its fraction, it will be a, or with a positive exponent, it will be a over x to the power 1. Can you see the relationship now? It is relating to this now rule number 2. So now rule number 2 say leave the constant a value k. So our constant is a here. And then now this will be taking a ln of x. Remember, you have integrated, that is a plus c. That is why we are having this condition here. It is covering for this type of a question that b cannot be negative for this particular application, grade 12. Okay, I hope we are still together. Now, and then let's look at the next application. Can you see now we have exponent 2. Exponent 2 means what, grade 12? We are having 2 bracket of 3 minus square root of x. 2 brackets of that. That means you need to work out your brackets and simplify them. It is only then that you will integrate. Can you see? It's the same thing that you do when you derive in differential calculus. You cannot derive if you are having the brackets that need to be simplified. Let's simplify as far as possible where there's a need before we integrate, right? And then now let's look at number 6 here. We are integrating. So we have 2 brackets of 3 minus square root x. That exponent 2 means 2 brackets of the same thing. And then we are integrating with respect to x then. Right, because we are busy simplifying the brackets, we will still write our integral sign. That will be 3 times 3 there, it's 9. And then 3 times square root of x, that will be minus 3 square root of x. And then minus square root of x times 3, that will be minus 3 square root of x. And then lastly, the minus square root of x times the minus square root of x, it will be plus x. The square root of x times the square root of x is the same as square root of x squared, because we have 2 of them. Then the 2 will cancel the square root sign. That is why we say the answer will just be x. And then remember, we are deriving with respect to x there. And then now we can now add the like terms, because we have like terms there. Remember, we are still simplifying. We have 9. And then we have minus 3 square root, minus 3 square root, which will be minus 6 square root. But this square root now, grade 12 will write it as x to the power half, which is the same as the square root. Remember, square root of x is the same as x to the power half. And then we have plus x there. We still have to derive, to integrate in terms of x there. Now we have now simplified this expression. we can now start integrating. Now we relate this to our question. Remember, we've indicated if it's just a number, let's put x to the power 0 there. Now let's check. Is 9x to the power 0? Do we have a value that is having an exponent x? No, we cannot apply this one. And then do we have an x that is on the denominator, x to the power 1 or x to the power minus 1? No, that means it's the application of rule number 1. Can you see grade 12? In most polynomials, rule number 1 is playing a major role there. And then now let's integrate now. So it will be 9x to the power, we will be adding 0 plus 1, which is 1 over 1, okay? Minus 6x to the power half plus 1 is 3 over 2 over 3 over 2. Plus x to the power 1 is 1 plus 1, which is 2 over 2, plus c because we are integrating. Can you see that now, grade 12? Our final answer will be 9x. And then with the second one now, look at this. We are having 6x to the power 3 over 2. And then we are dividing this by 3 over 2. Correct? So this is the same as 6x to the power 3 over 2 times 2 over 3. Because if you change the division to multiplication, you must take the reciprocal of that one. So that means now our answer will be 6 times 2, which is 12 over 1 times 3, which is 3 then. And then x to the power 3 over 2. So that is the simplified part of this expression there. So this will be minus what? 12 over 3. And what is 12 over 3? 3, 6, 9, 12, that is 4. So, or you can take your calculator and say 6 divided by 3 over 2. It will take you straight to that 4. That is minus 4 x to the power 3 over 2 plus a half x squared plus c. So that is your solution, grade 12. So let's look at the mark allocation now. How do we mark this one? We are going to mark the simplified expression, of which is this trinomial here. After simplifying everything, that's the first mark. The second mark will be for the first integral, the second one, second integral, the third one for the the third integral. Sometimes they give a mark for the plus c. If it is not given, it will be grouped with one integral here. So that means grade 12, basically, this means this question can worth 4 to 5 marks, okay? 4 to 5 marks at maximum, okay? The next activity, okay, grade 12, try this one on your own. Number 7, remember you always use your rules to relate the question to the rules, integrate individually. So, and then now this will make your life easier. I'm giving you 3 minutes to do number 7. Your 3 minutes starts now. Okay, grade 12s. Let's see how far did you go with this one on your own. Remember to send your clarity seeking questions to our WhatsApp number 079 578 2908. Repeat 079 578 2908. All right, let's look at the question now. Remember the tip I gave you earlier on is separate your integrals, simplify them as far as possible, ensure that you don't have set on your set notation on your expressions. Number one, already on this one, you're having a challenge of the square root there that we need to get rid of, okay, and write that in exponential form. So since we are going to deal with that now, we are still going to note our integral sign, and then we are integrating the square root of x, which is x to the power half, plus you can separate them and integrate one by one. Separately, integration of 6 over x plus the integration of 8x to the power minus 5, and then we are integrating with respect to x there, right? And then after now clearing everything, relate now. Try to find a relationship between your rules and your integral. Number one, we are having x to the power half, okay? Can you see that is rule number one? 6 over x, rule number 2, grade 12. 8 to the power 8, x to the power minus 5, rule number 1. Can you see rule number 1 is repeating more often, okay? Be careful of that rule. Do not mix them up, right? We know it's rule 1, it's rule number 2 here, and then it's rule number 1 again there. Then let's apply the rules. Then we are now starting integrating. That will be x to the power half. Remember, the method is plus 1, and then your exponent, you take it to the denominator. And then plus the second one, rule number 2. Rule number 2 says take a constant value, start with your constant value, which is x there, and then you bring the ln of x there. And then now the third one, it's rule number 1 again, it's 8x. Rule number 1 is minus 5 plus 1, denominator minus 5 plus 1. And then remember, you are now integrating, it will be plus c. I hope we are still together. And then now let's simplify. Half plus 1 is 3 over 2, therefore is x to the power 3 over 2 over half plus 1, 3 over 2 on the denominator there. Plus 6, this one is already simplified as it is. And then now we are having plus 8 x to the power minus 5 plus 1 is minus 4 over minus 5 plus 1 minus 4 plus c. Can you see now? Exponent must be the same as your denominator. Rule number 1, exponent must be the same as your denominator. And then now first term there, we are dividing by 3 over 2 is the same as multiplying by 2 over 3. That means it will be 2 over 3x to the power 3 over 2. Plus 6 ln x. And the 8 divided by minus 4 is a minus 2. X to the power minus 4 plus c. We can leave it like that, or you can write this with a positive exponent. That will be 2 over 3x to the power 3 over 2 plus 6 ln x, and then this one will be minus 2. Remember, the negative exponent is only on x, therefore you are taking that one to the denominator. It will be x to the power 4, and then we have the plus c there. I hope grade 12 you end up getting it correct. So this will worth 4 marks. That will be 1 for each integral there, and the plus c value there. Okay. And then the number 8, we are look at this, we are integrating in terms of x. That is what is important. Even though now they've brought different letters in our expression, but what is important is the key directive that we are given with respect to x. That means this t now will treat it as if it's a number now, okay? because we are deriving in terms of, we are integrating with respect to x grade 12. Please don't confuse the two, integration and differentiation. They look the same application, but remember each is having its rules. Now we are integrating, we apply the integral rules, okay? Right. Let's look at the expression now and check is relating to which rule, okay? Number one, we need to get rid of this root sign before we can start with our integration. So now we are having integration of t over x minus x squared and then t to the power. Remember now it will be t to the power 2 from the inside the root sign or the set form, and then now the square root will be to the power half. So this is the same as 2 cancel 2, there is t to the power 1. Can you see now we'll end up with only t grade 12 from that explanation, all right? And then now because we are still simplifying, we are going to write that with respect to x. And then now let's start integrating. We start by looking at the rule, which one is suitable for this one, okay? Now is t over x to the power 1, that means is rule number 2. Rule number 2 for that one. And then we have minus x squared t. Remember t is a value, we can even write this as tx squared. We assume this t is representing a certain value. Therefore it's rule number 1 because it's x to the power value then, exponent 2. Right, and then now this is rule number 1. We have identified our rules now. We can now start differentiating. For the first one, rule number 2 says that write the constant value first. Our constant value is t then, and then this will be ln of x, right? And then second one, it says take rule number 1, that will be minus tx squared plus 1, denominator 2 plus 1, and then plus c because we have integrated that. And the answer will be t ln x, and then simplifying this one, it will be tx to the power 3 over 3 plus c. So that is your answer, grade 12. And then now our marks will be for simplifying this one here, first mark there, the second mark for the integrated one, second integral then, and then the third one will be for c there. So the total mark for this expression will be 4 marks. I hope grade 12 we are still together. And then now I want you to try number 9 on your own and then reflect back with all the information that I've indicated to you in terms of brackets and so forth. Let's see how far can you go with this one, grade 12. 3 minutes, your 3 minutes starts now. Okay, grade 12, let's see how far did it go. Our WhatsApp number, remember, 079-578-2908. You can send your clarity seeking question to that particular number. Repeat, 079-578-2908. Right. What is the starting point, grade 12? We must get rid of the brackets, simplify as far as possible, because in this case we are having 3 multiplications now. So we are going to leave that 2x for now and start with the bracket. Both must rule brackets first. But if you look at this, these are difference of 2 squares, right? You can have the shorter answer if you can be able to identify that these are difference of 2 squares. Or alternatively, you can continue with your distributive law of multiplication. It also works with this one. Okay, that is x times x, which is x squared. The x times 2, that is a 2x. And the minus 2 times x, that is a minus 2x. And the minus 2 times 2, that is a negative 4. And then we are integrating with respect to x. We are still simplifying, grade 12. You can't integrate before you simplify as far as possible. So we are still integrating now. These two, can you see now, 2x minus 2x will give us a 0. So we are left with 2x into x squared minus 4 inside the bracket. So now we are going to multiply with the 2x now. We are still simplifying. We bring down the integral sign. So it's 2x times x squared, which is 2x cubed. And the 2x times minus 4, which is minus 8x. We are integrating with respect to x. And then now continue, grade 12. Happy, everything is now clear. Simplified. We can't add this. These are not like terms because the first term is x to the power 3. The second one is x to the power 1. But this x is not in the denominator, grade 12. You cannot apply rule number 2. That means for both of them is rule number 1. Can you see the importance of rule number 1? Yes. Now let's integrate. It's 2x to the power 3 plus 1. Denominator 3 plus 1. Minus 8x, 1 is our exponent there, and then plus 1 for integrating, 1 plus 1 denominator. Exactly the same exponent, and the denominator must be the same after integrating, right? And then we have plus c because we have integrated. And then now let's simplify this. We are having 2x to the power 4 over 3 plus 1 is 4. And then minus 8x to the power 2 over 2 plus c. And then this is equals to now 2 over 4 simplified fraction is 1 over 2. Therefore, it will be 1 over 2x to the power 4. Minus 2 into 8 4 times, that will be 4x to the power 2 plus c. That is your answer, grade 12. And then the first mark will be for simplifying the 2 bracket, the second mark for the simplified expression, the third mark for the first integral, second integral for the plus c. So this problem worth 5 marks, grade 12. Can you see integration? We have a lot of marks there, and then you just use your rules, grade 12, to find the answers there. And then now the last activity for you, grade 12. Try this one. We are having pi's, we have an exponent x, and so on. Let's try to answer this one, grade 12, and see how far can you go on your own. Your 3 minutes starts now. Okay, grade 12. Let's see how far did you go with this one. I hope now you're going to get 100% correct, right? Remember to send your clarity seeking question to our WhatsApp number 079 578 2908. Right. Remember, the first thing that you do, you look at the expression. Does it need to be simplified, grade 12? No, we don't need any simplification here. And then do not get confused by seeing a pi to the power 2x squared and try to add maybe to x to the power pi. Remember, the pi on the first one is a base, on the other one is an exponent. Therefore, those two are not like terms. You can't add them together, grade 12. Now, we can start identifying the relationship of rules that are involved in this particular expression. Now, remember, we will be integrating them individually. Integration of 2 to the power x minus integration of pi to the power 2x plus the integration of x to the power pi. And then we are integrating with respect to x then. Then we check, okay, the first one, we are having a number to the power x. Can you see x is an exponent? Therefore, it's rule number, grade 12. That is rule number 3. 1, 2, 3. That is rule number 3, where you have x being an exponent there. So for this one, we will be applying rule number 3. And then for the second one, remember a pi is a number. It's like we are having 3,14 or 22 over 7 to the power exponent 2 over x. Can you see that? It's a number. Our exponent is having a coefficient 2 now, 2x, but x is on the exponent. Can you see now is the rule number 3, but the second application there, because there's a coefficient on and there. Okay, that means the second one will be applying rule number 3. And then we have integration of x to the power pi now. It's x with an exponent being a number there. As long as that exponent is not minus 1, therefore it falls on rule number 1. Right. If it's x to the power minus 1, remember it's rule number 2, because this is the same as 1 over x. Okay, so for this one, it's rule number 1. Can you see, grade 12? Now we have rule 3 and rule 1 to apply here. Happy now, we can now give the answer. The first one is 2 to the power x. That means now the expression on top, numerator will be the expression as it is, 2 to the power x, and then the denominator will take the lead of a. Our a in this case is 2. And then now minus the integration, we said, is a rule number 3 again, but our x is having a coefficient. That means we are applying this one. Let's see now. It says start with the constant value. Okay, and then the constant value here, we don't have constant value, grade 12. Constant is the one that is before the pi there. Lucky enough for this one, we don't have. So now, if we don't have the constant value, now write whatever you have on top as it is. So we have pi to the power 2x as our numerator. For denominator, it says take the coefficient of x, which is n. In this case, it will be 2. And then you bring the limit of a. Our a is a pi there. Can you see that, grade 12? And then now, lastly, we are integrating with rule number 1. Rule number 1 is a plus 1 plus 1, okay? So that is x to the power pi plus 1, and then the exponent must be the same as the denominator, pi plus 1, and then that is plus c, because we have now integrated. And then do we need to simplify anything here? No. Therefore, grade 12, this is your answer for that particular integration. Mark allocation now, it will be 1 for the first integral there, the second one for the second integral, the third for the third integral, and the fourth mark for indicating that there's a plus c. So this can be maximum 3 or 4 mark allocation. So in this case now, I will give this one a 4 marks. I hope, grade 12, you managed to get that 4 marks. And then this brings us to the end of today's lesson. And this lesson was brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Till we meet again, grade 12. Bye.